Hello everyone, welcome to all in this video lecture series of Database Management System. I am Deepak Aneja, Assistant Professor, ABS Engineering College, Ghaziabad. In this video, I will cover the topic candidate key. This is very important topic to understand the concept of candidate key. Yeah, how to find out the candidate key. We need to understand the attribute closure first. So first, we need to understand what is attribute closure or closure set. Attribute closure of an attribute set can be defined as set of attributes which can be functionally determined from it. Now, let us take an example. How to find the attribute closure of an attribute set. There is a relation R. Attributes are A, B, C. The given functional dependencies are A determine B, B determines C. If we find the closure set of A, we can represent this closure set of A by this symbol, A closure set. Then we will calculate A determine B. So A से A determine होगा ही होगा. Then from the A we can determine B. From B we can determine C. So the closure set of A is A, B, C. If we need to find the closure set of B, then from the B can be determined, and from B, we can determine only C. Now, from the C, closure set of C, we only just determine only C. So attribute closure of an attribute set that can be defined a set of attributes which can be functionally determined from it. So closure set of A, we can functionally determine A, B, C. And from the attribute closure of B, we can only determine B and C. And from the closure set of C, we can determine only C. Now, let us take one more example. Consider the table student having roll number, student name, marks, location as the attributes and having two functional dependencies that are given. Roll number determines student name marks and student name determines marks location. Now we will calculate the closure of all the attributes present in the given relation. So attributes are roll number. Now closure set of roll number. We can determine from this roll number. From this roll number, we can determine student name and marks. And marks. And from this student name, we can determine marks as well as location. So no need to repeat the attribute name here. So we can determine location also from the student name. Now attribute closure of student name. We can determine student name through the reflexivity or trivial functional dependency. Then from the student name, we can determine marks and location. No further attribute can be determined from these. Next, from marks, attribute closure of marks. And determine marks. From the marks, we cannot determine anything else. Then attribute closure of location. Only just location. No other attribute can be determined from this location. So these are the attribute closure set of roll number, student name, marks, and location. Now next. Now let us understand the concept of candidate key. Candidate key we already studied in the previous unit. Here we can understand the concept how to calculate or how to find out the candidate key. So first of all, candidate key is used to identify the tuples, rows uniquely. So candidate key uniquely identify the tuples in a table or in a relation. Candidate key is a minimal super key. Candidate key is a minimal super key. For example, if A is the candidate key, then from the combination of candidate key AB, ABC, these are the super key. These are the superset of candidate key. So that's why these are called super key. Now, how to find the candidate key for a given relation? Consider the relation schema R. Attributes are E, F, G, H, I, J, K, L, M, N. And the set of functional dependencies that are given, EF determine G, F determine I, Ij, EH determine KL, K determine M, L determine N on relation R. Now we have to find out the candidate key R. This is the gate question, comes in CS 2014. Now, how to find out the candidate key in this question? So there is a trick to find out the candidate key. So from the given functional dependencies, the right hand side attribute, we have to check the missing attribute from the right hand side in the given functional dependency. Here, G functional dependency is given, I, J is also given, K, L is also given, M is also given, and N is also given. So here are the missing attributes, E, F, H, E, F, H. So candidate key is, is determined through the combination of from that attribute we can determine all the attributes of a relation R. So E, F, H are the missing attributes from the right hand side. What it means, we cannot determine E, F, H from any of the given functional dependency. So we must need to take this is the part of candidate key. So let us take the attribute closure of EFH. From this, we can determine EFH, and from the EF, we can determine G. From the F, we can determine I, J. From the H, we can determine KL. From the K, we can determine M. And from the L, we can determine N from the given functional dependency. Let us check all the attributes of a relation R can be determined from EFH. Yes, E, F, G, H, I, J, K, L, M, and N. Yes, from the attribute closure of EFH, we can determine all the attributes of the relation R. So we can say that EFH is the candidate key. Now, these are the missing attributes from the right hand side. So there is no possibility of more than this candidate key. So this is only the candidate key for this question. Now let us take one more example. There is a relation R. Attributes are A, B, C, D, E. The given functional dependencies are A determine B, BC determine E, D determine A. We to find out the candidate key. So let us follow the same trick. From the right hand side, there is B, available attribute is B, E, and A. Missing attribute is C, D. Now try from this set CD. Now take the attribute closure of CD. We can determine C, D. From the CD, we cannot determine anything else. So now this is not the candidate key. Now we have to pair this with the another attribute. Now CD must be these are the missing attribute from the right hand side. So these must be the part of the candidate key. So let us pair with this CD attribute. There is A CD combination is ACD, BCD, CDE. There is no more combination with the CD in the pair of 3. Now take the attribute closure. From this, we can determine ACD. Now we can determine from A to B. Now BC. From BC to E and DE to A. A already is the part of this attribute closure. So we can determine all the attributes of the relation are A, B, C, D, E. So this is the first candidate key that we have calculated. Now take the attribute closure of this. There can be multiple candidate key. So we try to all the possibility. So B, C, D is the part of this attribute closure. Now from the BC we can determine E, and from the DE we can determine A. So all the attributes can be determined from BCD. So there is one more candidate key, BCD. Now take the attribute closure of CDE. CDE is the part of candidate key. Now from DE we can calculate, we can find A, we can determine A, then A to B. So A, B, C, D, E. All the attribute of relation are. So C, D, E is one more candidate key. So there is no pair is failure. So there is no possibility of another candidate key. So this is the final answer of. Now let us take one more example. There is a relation R, A, B, C, D. A, B determines C, D, C determine A, D determine B. So given functional dependencies are A, B determines C, D, and C determine A, and D determine B. So find out all the candidate keys. So same trick, C, D. A from the right hand side and B is also present in the right hand side. So there is no missing attribute from the right hand side. Now we have to start from the to check from single attribute. Now take A, B, C, D. Closure set of A, B, C, and D. Now find out the attribute closure of A. A to A, we can determine A. There is no further we can determine. Further attribute can be determined from this. Now from the closure set of B, we can determine B. There is no further attribute that can be determined from this. This is failure. This is failure. From the C, we can determine C. From the C, we can determine A, or there is no further attribute we can determine from this. So this is also failure. Now from the D, we can determine D. From the D, we can determine B, and from there is no further combination that can be determined from this. Now we have to combine pair of two attributes. This AB, AC, AD, BC, BD, CD. Now let us take the attribute closure of all. Now take, we can determine AB, then from AB we can determine CD. So here we can determine all the attribute of relation R from AB. So this is our first candidate key, that is AB, that we have determined. From AC we can determine A, C, and from C we can determine A, then there is no further attribute can be determined. So this is the failure case. Now from AD, we can determine AD, and from D, we can determine B, and from AB, we can determine CD. So we can determine all the attribute of the relation R. So AD is the another candidate key. Now take the attribute closure of BC. B, C, from C, we can determine A, and from AB, we can determine CD. So this is another candidate key BC. Now take B, D. From the D, we can determine B. There is no further, so this is the failure. Now from CD, C, D, and from C we can determine A, and from D we can determine B. So this is another candidate key. So there are two failures, AC and BD. AC and BD. BC is also. So there is no further combination from this. This is the candidate key. Now let us take one more example. Consider the relation R. Attributes are W, X, Y, Z, and set of functional dependencies. Z determine W, Y determine XZ, XW determines Y on R. Now same trick to find out the candidate key. Let us take the missing attribute W, W, X, Z, and Y. There is no missing attribute. Now try from the single X, sorry, W, X, Y, Z. Take the attribute closure of all the single attributes. Now from W, we can determine W, and there is no further attribute we can determine. So this is the failure case. Now from X, we can determine X, or from X, we cannot determine anything else. So this is also the failure case. Now from Y, we can determine Y. From the Y, we can determine XZ, or from the Z, we can determine W. So we can determine all the attributes given in the relation R. So this is our first candidate key that we have found. Now take the attribute closure of Z. We can determine Z. From Z, we can determine W, and there is no further. So this is also the failure cases. Now if we pair the attribute with the y that are the super key. So we need to find out only the candidate key. We don't have to find out the super key. So here we will pair the combination with the failure cases. So failure cases are W, X, and Z. Now we can combine with the two attributes. We will pair with the two combination WX, WZ, XZ, then no other pair. So let us take the attribute closure of WX. WX. So here is XW. We can determine Y, or from the Y we can determine XZ. So we can determine from WX all the attributes that are present in the relation R. So this is another candidate key VWX. Then WZ. WZ we can determine from WZ. Then from the Z we can determine W. Then no other attribute we can determine from this. This is also the failure cases. Now XZ, we can determine XZ. From Z we can determine W, or from XW we can determine Y. So this is one more candidate key XZ. Now the failure is only WZ. There is no other pairing. So there is no other candidate key exists. So this is the final answer. These are the candidate key of the relation R. So this is very important concept that I always ask in GATE, NET, university exam, as well as placement. So I hope all can understand. So these are the references. So thanks for watching this video.